Welcome to Learn Yourself. Today we are going to learn and understand about chapter 12 electricity. In this our first topic is electric current and circuit. These are the basic information about electric current and circuit. So electric charge flows through a conductor. Now what is the meaning of conductor? Conductor means any simple wire or a metal rod which will allow electricity to pass through it. So they should be good conductor of electricity. That's why they are known as conductor. Electric charge flows through a conductor. A switch makes a conducting link between the cell and the bulb. If we will see the circuit, then here if a bulb is there and at the bottom I have made this switch. So switch is a conducting link. So when the switch is closed, it will be something like this. So this makes a complete circuit. When switch is open, then that circuit is not complete. So when the switch is on, the bulb will glow. So the switch is a conducting link. That means it will conduct a current which will glow a bulb. So that's why it is a conducting link between the cell and the bulb. Now to pass electricity from this conductor, we need to have one cell over here. So this is our battery, which is a cell. This will produce a current which will glow a bulb. So this switch is a conducting link between this battery and bulb. A continuous and closed path. It shouldn't be break from anywhere. Otherwise, current will not flow from the circuit and bulb will not glow. So it should be continuous and closed path for an electric current is called an electric circuit. So this is electric circuit which is continuous and closed path. The amount of charge flowing through a particular area in unit time is known as electric current. So what will define the electric current? That the amount of charge, whatever charge is passing from an electrical circuit flowing through a particular area. For example, this area we have chosen, and here the charge is passing from this particular area in unit time. So this is defined as electric current. In an electric circuit, the direction of electric current is taken as opposite to that of the direction of the flow of electrons, which are negative in charges. Earlier, when the electricity was invented, at that time the people were believed that these are the positive ions which are flowing through the circuit, and the direction of the current and positive particles direction are same. But eventually scientists got discovered that into the electric circuit the direction of electric current. So for suppose an example, this is a conductor. So if in this direction the electric current is flowing, then in opposite direction flow of electrons will be there. And electrons are negatively charged particle that we know. So electrons are flowing in opposite direction than that of this electric current. Now let us understand our first formula for the electric current. So if a net charge Q flows through or across any cross section of a conductor in time t, then the current I through the cross section is, any cross section means we are taking a piece of conductor that is this much, and from this much piece of conductor or through this cross section the Q charge is passing, and it is taking t time to pass from this end to this end. At that time the current passed from this cross section will be I. So that we will get it from I equals to Q by T, where Q is a charge, T is a time, and I is current. Now 1 coulomb charge equals to 6 into 10 raised to 18 electrons. Earlier we have seen that when current is passing in one particular direction, for example left to right, then electrons will pass from right to left, and that is in opposite direction of the current. If this is our direction of the current, then this will be the direction of the electrons. Electrons are negatively charged particle, and they will flow in opposite of the current. Now when 1 coulomb charge will pass, this is our cross section from here till here. If 1 coulomb charge is passing at time t, then how many electrons will flow in opposite direction? So 6 into 10 raised to 18 electrons will flow in opposite direction when this many electrons will flow from right to left, and whatever time it will take, during that time we can say that 1 coulomb charge has passed in this direction, that is left to right, because if electrons are flowing from right to left, then current will flow from left to right. And when 6 into 10 raised to 18 electrons will pass, at that time we can say that 1 coulomb charge has passed from this cross section of the conductor. We know that 1 electron's charge is 6 into 10 raised to minus 19 coulomb. That is, this much charge will have per electron, and we have this many electrons in 1 coulomb. Now whatever current is passing through this circuit is given an unit, that is ampere, and it is named after a French scientist, Marie Ampere. So what is an ampere? So 1 ampere is constituted by the flow of 1 coulomb of charge per second. So when 1 coulomb of charge is flowing from conductor in 1 second, at that time we will say that 1 ampere current has passed from the circuit. So 1 coulomb of charge will pass in 1 second. So that much current we will consider as 1 ampere current. Now this is our circuit, where in this represents cell or a battery which has 2 different terminals, negative and positive. In this cell, small line represents negative terminal and big line will represent positive terminal. This is a key. A key is a conducting link between a cell and a bulb. Here this A represents ammeter. Ammeter is a device which will measure the flow of electric current through the circuit. An ammeter we are always connecting in series along with the circuit. This is our bulb, and here this current is flowing from positive terminal of the battery to negative terminal of the battery. So this we have to keep in mind, that whenever we are showing a flow of current in a circuit, it will be always from positive terminal of the battery to negative terminal of the battery. So the flow direction will be from positive to negative. So this arrow represents that it comes out from here and it passes through the bulb. Bulb will glow when the switch is on, and again it will pass from the ammeter, which will measure that how much current is flowing through that. This is a key, and again it will comes back to the negative terminal. Current will flow from positive terminal to negative terminal, and electron flow will be opposite to that. That means from negative terminal to positive terminal. So hope this video has solved your doubt. In coming videos we are going to cover some important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.